To continue on about today about chemical reactions, what they are, as well as how do we balance a chemical reaction. So first of all, a process in which one or more substances is changed into one or more new substances is called a chemical reaction. So that's what a chemical reaction is. And I'm trying to push. Okay, there we go. A chemical equation is uses these chemical symbols to show what happens during a chemical reaction. So here are depictions of a chemical reaction of hydrogen and oxygen to form water. You can either use pictures like this. Okay, we're not going to be doing it this way, but you can use pictures like this. This is a hydrogen molecule or two hydrogen molecules in words here. And one oxygen molecule, written as words, makes two water molecules, written as words or as pictures. We're going to instead be using chemical symbols. So in a chemical equation, as it says right there, we use chemical symbols. H2 is hydrogen, O2 is oxygen, water you probably know is H2O. To say that I have two waters, I put the coefficient 2 in front. To say I have two hydrogen molecules, I put a coefficient 2 in front. One oxygen molecule, it's not written here, but if there's nothing written, we assume it to be 1. Just like when you see x plus y in math, it's assumed that's a 1x plus 1y. We usually just don't write 1s because a 1 it just will look it'll just make it look messy. So in a chemical reaction, we use chemical symbols and numbers in front representing how many of each one there is to show what happens in a chemical reaction. So this is a chemical equation. In a chemical equation, we always have reactants on the left side of an arrow. Reactants are the things that are reacting, kind of like your ingredients in a recipe. Your ingredients would be your reactants. What you make would be on the right side of the arrow. They're also known as your products. So the products are on the right side of the arrow, the reactants are on the left side of the arrow. In this chemical reaction, hydrogen and oxygen they are the reactants. And water it's a product in this reaction. So in chemical reactions, we always have an arrow that separates on the left side reactants, products on the right side. Reactants on the left side, products on the right side. Reactants on the left side, products on the right side. Reactants on the left side, products on the right side. Reactants on the left side, products on the right side. Reactants on the left side, products on the right side. So you should be able to tell, hey, if I have an arrow, the stuff on the left, they are the reactants. The stuff on the right are the products. Okay, so how do we read a chemical equation? Well, I know on the left side, they are my reactants, and on the right side on my arrow, I have my products. Okay, but this thing, how I could read it, there's multiple ways I can read this equation. One way is just right there. It says 2 atoms of magnesium, 1 molecule of oxygen makes 2 formula units of magnesium oxide. Technically, magnesium oxide is ionic. Ionic things we don't call molecules because they're not technically molecules, so we say formula units. But if you call that a molecule, for the point of this, fine. Okay, but 2 atoms of magnesium, 1 molecule of oxygen makes 2 formula units of magnesium oxide. Coefficient 2, coefficient 1, coefficient 2. 2 atoms of magnesium, 1 molecule of oxygen makes 2 formula units of magnesium oxide. Okay, another way we can read it is this. 2 moles of magnesium and 1 mole of oxygen makes 2 moles of magnesium oxide. That's how we're probably going to be reading most of the stuff in this chapter. 2 moles of magnesium, 1 mole of oxygen makes 2 moles of magnesium oxide. You could also theoretically have said, 2 dozen magnesiums, 1 dozen oxygen makes 2 dozen magnesium oxide, but the units that we use in chemistry are going to be moles, okay? So 2 moles of magnesium, 1 mole of oxygen makes 2 moles of magnesium oxide. There's one thing that the most common mistake students make on this, okay, when they're reading chemical equation, is the following statement. Oh, well, not that. Sorry, not this is coming up. Well, I should just bring it up now. So this is the most common mistake that students make. They say this part here in red. 2 grams of magnesium, 1 gram of oxygen makes 2 grams of magnesium oxide. This is wrong. This statement here in red is wrong. You're like, but it says 2 magnesiums, 1 oxygen, 2 magnesium makes 2 magnesium oxide. Yes, in moles or in molecules or atoms, but not in grams. If you wanted grams, you would have to convert moles into grams. How do I convert moles to grams? You would have to look up on the periodic table 1 mole of magnesium oxide. The molar mass of magnesium oxide is 24.3, so 2 times 24.3, 48.6. Oxygen on the periodic table is 16. This is O2, so 16 times 2 is 32. Magnesium on the periodic table again is 24.3. Oxygen 16. Add that up and you get 40.3. So yeah, it's 40.3, but you have 2 moles of it, so 2 times 40.3, and you get 80.6. So if you wanted grams, you would have to convert the moles into grams using the molar mass on the periodic table. You cannot just say the statement, oh, 2 grams of magnesium, 1 gram of oxygen makes 2 grams of magnesium oxide. This here in red is wrong. That's the most common mistake that students make. You cannot say these in grams. For instance, if you had a recipe for cooking, if your recipe said 2 cups of flour, 1 cup of sugar makes a dozen cookies, you can't say, oh, we'll take a gram of sugar or 2 grams of sugar and a gram of flour. No, the recipe said 2 cups of sugar. You can't just change it to weights like that. So if you want them in weights, we first have them out in moles and change your moles into grams using a periodic table. Okay, so that's how we, quote, read a chemical equation. Next thing we're going to get to is balancing chemical equations. This is probably something I'd say 70-80% of you guys have done before in a different class. So for many of you, this is review, and for the rest, obviously, it's not review. And for those of you who where this is brand new, it's not hard. It just takes a bit of practice balancing chemical equations. So it's not that hard of a topic. But when we balance chemical equations, first of all, you must write the correct formulas of the reactants on the left-sided arrow. Reactants go on the left-sided arrow, and correct formulas of all the products on the right side of the arrow, or right side of the equation. So if you had a statement that says this, ethane reacts with oxygen to make carbon dioxide water, you first need to know, what are my reactants, what are my products? There are 2 reactants and there are 2 products. So the questions are, what are the reactants and what are the products here? So you should probably see that in this equation, ethane reacts with oxygen to form carbon dioxide water. The reactants will be ethane and oxygen. They're reacting. And it forms, so the right-sided arrow will be carbon dioxide water. So on the left-sided arrow, I know you don't know what ethane is. I would tell you that on a test or, anything like that in this chapter. So whatever ethane is, the chemical formula, I'll just tell you, it is C2H6. You've never seen it before, so I'm just telling you it is. Oxygen, ethane and oxygen reacts to form, that's our arrow. Products are carbon dioxide, you should know the formula carbon dioxide, CO2, and water, H2O. So first thing to balance the chemical equation is make sure you have an equation to balance, okay? And when you have the chemical equation, the formulas have to be correct. H2O is water. If you put H2O2, that's not water. Carbon dioxide is CO2. If you put CO, that would be carbon monoxide. This statement here didn't say carbon monoxide. It said carbon dioxide. So you have to have the correct formula of each. Okay. Next thing to balance chemical equations, we change numbers in front of formulas or the coefficients to make the numbers of atoms of every element the same on both sides of the equation. We do not change subscripts. So for instance, if I want to have 2 ethanes, I say this, put a coefficient 2 in front, 2C2H6. Do not change the subscripts. Do not change the C4H12. This is no longer ethane, okay? This is something else. Again, this is H2O's water. If you change to H2O2, that's not water anymore. H2O2 is hydrogen peroxide. If you put CO, as you already know, CO is carbon monoxide. So you can't change the numbers at the bottom. You can only change the numbers in the front. also known as the coefficients when we're balancing chemical equations. Okay, this equation is not balanced, so let's start looking at that equation. Here it is. That same equation just copied over. Where do we start? We always start by balancing elements that appear in only one reactant and one product. In this case, I'd say maybe carbon. Notice on one thing on the left side, one thing on the right side. Or you could even start with hydrogen. There's just one reactant on the left side, one product on the right side. Do not start with oxygen. The reason why, notice it's found in two different products. So we'll start with, say, carbon. First question, how many carbons are right there in the C2H6? Okay, so again, start with carbon, hydrogen, but not oxygen. How many carbons are right there? 2. It says so, C2. There's 2 carbons there. How many carbons are here in CO2? Okay, well, obviously 1. And they're not equal. For them to be equal, what I'm going to do is I need to put a coefficient, a number in front of this carbon dioxide. That times 1 would equal 2, and I think that'll be obvious what I'm going to do. I need to multiply the carbon dioxide by 2, or put a coefficient of 2 in front of the carbon dioxide. Now I would have 2 carbons on the left side, 2 carbons on the right side. Carbon is now balanced. That's only one element. We still have the other 2, so just hold off in case you're wondering about what about the other elements. Okay, we only did one element so far, and that's just carbon. Now, let's look at hydrogen. We're doing hydrogen before oxygen because oxygen is in 2 different products. How many hydrogens are right there in C2H6? Well, as it says, there's 6. H6. How many hydrogens are in the water right there? H2O. Okay, well, obviously 2. They are not equal. But if I multiply 2 times something, I should get 6. 2 times what equals 6? I think that's a pretty obvious one. 2 times 3 equals 6. So I'm going to multiply the water, or in other words, put a coefficient in front of the H2O with a 3. 3 times 2, 3 H2s is 6 hydrogens, and there's 6 hydrogens. Okay, so now the carbon is balanced. There's 2 carbons on the left, 2 carbons on the right. There's 6 oxygens on the left, 3 times 2, 6 oxygens on the right. We still have to do the oxygen, that's next. And that's going to be the next slide. So let me copy this equation. Here it is. There it is. Okay, so just copy. Okay. So next thing, we need to balance equations that are in 2 or more reactants or products. In other words, is the oxygen. On the left side, you can see I have 2 oxygens there. So how many oxygens are on the right side? Well, on the right side, kind of a slightly trick question, not really. In the carbon dioxide, I see 2 times O2s. I have 4 O2s there. But that's not the only oxygen. I also have 3 oxygens right here. So I have 4 oxygens, 2 times 2, plus 3 more for a total of 7 on the right side. So I have 7 oxygens on the right, 2 on the left. Okay, I know that's not a nice whole number, but 2 times what equals 7? Well, I didn't say it's a nice whole number, but let's multiply by 7 halves right now. Okay, I know some of you is like, wait, you can multiply halves? Okay, hold on that. But as you can see, 7 halves times 2, this would be 7 oxygens. And 2 times 2 was 4, plus 3 more, that's 7 oxygens. So mathematically, this is correct, but we can't have fractions in reality, or decimals for coefficients. So to get rid of that decimal, to remove that fraction, I'm going to be multiplying both sides of the equation by 2. 1 times 2, 7 halves times 2, 2 times 2, and 3 times 2. Again, 1 times 2, 7 halves times 2, 2 times 2, and 3 times 2. Now everything is a whole number. That equation there, hopefully, is a balanced equation. And that last step in balancing chemical equations is basically check your work in this equation like this. So check to make sure you have the same number of each type of atom on both sides of the equation. So let's check carbon. 2 times C2. 2 times 2 is 4. 4 carbons. Carbon is balanced. So 2 times 2, which is 4. Let's look at hydrogen. Hydrogen here, 2 times 6, which is 12. 6 times 2, which is 12. 2 times 6, 6 times 2. 12 on the left, 12 on the right. Next thing is oxygen. On the left side, 7 times 2, which is 14. 7 times 2, which is 14. On the right side, I have 4 times 2, which is 8, plus 6 more. 8 plus 6, which is 14. So in other words, the number of molecules or atoms of carbon on the left and right side is the same. Hydrogen on the left and right side is the same. And oxygen on the left and right side is the same. When that happens, you have a balanced equation.